All right, so the instructions for this is it's a polynomial. It says find all the zeros and graph the function. All right, and depending on what type of polynomial we have, typically if it's to the third power or above, there's a technique that we can use called rational root theorem. Okay, so again, implying that it's rational, meaning the number is either going to be a whole number or it's going to be a fraction, meaning one of the answers to the polynomial or one of the roots or zeros is going to be a nice number or a fraction. It's not going to be a decimal that doesn't repeat. It's not going to be a square root. So what we do is we find out what are the possible rational roots. And there's this method that we use, okay, and we do it by identifying P and Q. P is the constant on the back of the polynomial, okay, and Q is the coefficient in front of the highest variable, so 2 and 2. So P is 2 and Q is 2. So you put P over Q, and then we put their factors next to them. So the factors of 2 are 1 and 2. The factors of 2 are 1 and 2. All right? And then we make our different fractions. We'll start with this 1 right here. And that would make me 1 over 1 and 2 over 1. Okay. And then with the 2 down below, that would give me 1 over 2 and 2 over 2. 1 over 2 and 2 over 2. Okay. Now, when we use this, the answers are all positive or negative. They can be positive or negative. Okay. And we always try to reduce, or we try to get rid of any duplicates. Like, for example, 2 over 2 is the same as 1 over 1, right? Because they both equal 1. So I can get rid of the 2 over 2. So I have 3, or actually 6, unique, different possibilities that my answer could be. Okay, and what we do is we pick one. Literally pick any number. I'm going to choose positive 2. Okay. Now, here's the goal of what I do. I'm going to choose positive 2 and do synthetic division, which is the easiest way to check. Now, I know that 2 will be an answer if I do the synthetic division. My remainder is 0. If my remainder works out to be 0, then I know 2 is one of my answers because I need 3 of them because it's x to the third. Okay? So let's try out 2. Here we go. 2, 12, 15, negative 2. Okay, let's go ahead and bring down 2. 2 times 2 is 4. 12 plus 4 is 16. 16 times 2 is 32. 15 plus 32 is 47. 47 times 2, 94. So 92. Okay. So after doing all the work, and I realized, oh gosh, well, actually none of those are actually going to work out because, well, 2 is not going to work because my remainder is 92. So that means 2 is not one of my answers. Okay. Then again, let's pick it from the list. Let's try negative 1. Okay. Let's give negative 1 a shot. Why not? Again, I'm literally guessing and checking. There's really no rhyme or reason to it. But I'm going to do synthetic division again. And let's see if negative 1 will work out. So bring down the 2. Negative 2, 10. Negative 10, 5. Negative 5, negative 7. Okay. Closer, but still not it because I got a remainder on that one. Okay, let's try another number here. So we tried 2, we tried negative 1. Let's try negative 2. Sure, why not? Let's give it a try. All right, so 2, 12, 15, negative 2. Bring down the 2. It's going to give me negative 4. We have 8, negative 16, negative 1, positive 2. Hey, look at that. So 0, I got a remainder of 0, meaning one of the answers that I need to find for this is negative 2. So x equals negative 2 is one of my answers. And I know that because I got a remainder of 0. Then what you do from here is you would, so we start with x cubed, so that means we move down to x squared now. And then you would solve this right here. And again, we continue to that. But I just wanted to show to you the possible rational roots. So you make your list of possibles and guess and check to see which one works. And -2 works in this case. So that's how you find your possible rational zeros. And in another video, I'm actually going to continue how you would solve this and graph this.